All right, yo guys, we are reacting to the state of Unreal 2026, and right now we're getting into a part where we already explained that AI, we optimize stuff. AI is gonna be with Unreal, and it affects like almost everything from shaders, VFX, environment, level design, and even like programming with widgets and everything, right? Right now they're more about to talk about the workflow as an artist, and I wanted to make a separate video about this, so because the other video was kind of getting long, so yeah.
Thanks, Michael. Hi, everyone. My name is Pat Tubach. I've got a background in film and
Hey.
television. For media and entertainment, the MCP plugin that Michael just showed you opens up a wide range of new connections to LLMs, but also to image and video models like Nano Banana, GPT Image, Grok Imagine, Luma, Seedance, and many more. Michael was telling you about tools in the present, and I'm going to cover tools for creating linear content that are releasing early next year to give you control over these models. The standard approach to using an image model is to start by crafting a text prompt. In this
An
case, I
image.
wrote a novel
Oh my,
describing a
wait,
fictional
yeah,
city in
he
Happy
was talking.
Flanders, a
Oh
1950s
my god,
story.
he was naming a bunch. Oh my gosh, wait, isn't this generative AI?
Gather.
Am I
It's
tripping?
like professional situations where you have to hit story points, match exact continuity, and deliver what your creative director wants. You would typically
Oh my
communicate visually
gosh.
through sketches and previews. Unreal is great for that. So, to get started in Unreal, I scouted the Darrow
Okay.
Corridor scene from Quixel that's available on Fab, which I quickly customized to look like the gas station layout I needed. I worked in detail lighting mode since I was just using this for blocking to this stage. I dropped in some of the appropriate assets from that map: shelving, a propane tank, a cabinet, and also made proxy
Okay.
shapes for the assets that I didn't have: a long counter, more shelving, a cash register, and an ice chest. Then I backed up and framed my camera view and animated a boom down and a push in that I'd later use for my shot. But before I tackled the full video creation, I had to create a single style frame, the visual reference of my scene. To do that, I used the model to combine a depth pass plus the prompt novel I'd written before. The
What?
depth conditions the models to understand the layout and the framing. Here's how that works using our new tools in Unreal. I asked Claude Code,
Oh.
connected by our MCP plugin, to use Unreal's movie render graph to create a 4K image, plus all the rest. Asking for an Unreal render to create the image was a signal to Claude Code that I wanted to give my model my depth pass, but use the creative look described in my prompt. I then fired off that request. And while it was being generated, I inspected the graph that it made for the task. Image models are hungry for helpful data and conditioning, and so I prepared a process that pulls valuable visual data from the Unreal scene and passes it to the image model, in this case, Google's Nano Banana Pro. Now, let's take a look at this image more closely. You can see that it did a great job matching the visual detail I asked for, but most importantly, it didn't place
Wait.
things randomly. It matched the composition of my Unreal viewport exactly. From there, I could start to iterate.
Okay. Oh my gosh. I don't know if this, like, the rest of everything, right? I was okay. I was like, okay, this speeds up the workflow when it came to like making cities and everything. But I don't know how to feel about this. I don't know if I like this. I don't
For
think so.
example, I wanted another tire on the floor, but I didn't have that particular asset because it was an image model creation. Using the new image segmentation tools in the editor to mask the tire, I selected both the mask and the image, and with a predefined workflow, asked Claude Code to extract it, repair it, and mesh it using Tripo 3.1. And then I double-checked that graph, and I supervised the work. Now, of course, this is not a real-time process, so after several minutes, I got my textured tire mesh.
Oh.
I saved it to the content browser, where I then pulled in the tire and positioned it in 3D space. And finally, I asked Claude Code to add the tire to the image. Let's take a look at that result. So if we compare my UE passes with the tire in it, you can see that it put the new tire where I asked it to, and it made it look like a variation of the generated tire, not an exact duplicate. All right, now let's add something totally new to the scene by going back to the viewport for another round in 3D. I went browsing on Fab and found one of our junkyard reports for Megascans. I
Oh
picked the
my
specific tire piece that I
gosh.
wanted that had a 1950s look modeled into it to leave less to the image model's imagination. I asked Claude Code to add it to my image and make it look like it had been newly repainted. And after another image processing step in Nano Banana, that was done.
I don't
Okay, now that
know
I've
how
produced my
to
style frame, I was ready to go
feel.
back to our new Unreal tools to generate a video of our scene.
I don't
And here's my
think.
shot camera move again. If you recall, this is the move that I created at the beginning. Over on the right, I ran a sequence render node that represents the depth over the entire range. I'm going to
This
use the same depth
specific
restyling process with the video that I did on the still image. I supply the style frame I just generated to the linear model
function,
as image
I
frame
don't know
reference,
if I
and
like
you
it.
can see that I added a cat, just hoping for a bit of life. And then I set my video generation node to use Seedance 2.0, set the resolution, added audio, and then I was off. Once that process had run for several minutes, I had a video that looked like this.
Oh my gosh.
So clearly, this is showing you that I can control the camera, but nobody controls a cat. All right, let's leave the garage and the cat and move on to an apartment. This is a different workflow that we've been building in parallel for more rapid concepting with diffusion and your viewports side by side. What you're seeing here in this video
Okay.
is the UE viewport on the left that was streaming to a local Flux Klein image model on the right. The local model result isn't temporally coherent. It was stamping a new image on every frame and only running a few frames a second, which is why it seems slower
It
over there on the right.
changes
But let me show you how intuitive it is to use. I prompted for sunset lighting at first, and then decided to see what it would look like if there'd just been a fire in this apartment. And then I tried something more extreme, like being underwater at the bottom of a murky pond. The real benefit you get here is being able to go back to the UE viewport, interact with the assets, and see them repositioned through this new diffusion lens. Not only that, but you can try more illustrated looks, like a charcoal
But
drawing
it's not
or even a watercolor painting. As models get more capable and hardware improves, it's not hard.
yeah, it's not perfect. Like, it takes off the blinds though. It thinks that the blinds are like, or am I tripping? No, these are, hold on. Oh no, it's like a, yeah, there are blinds here.
Really coherent.
It
was
takes
stamping a
out
new image on every
the,
frame and only running a
and
few frames a
even
second,
like,
which is why it seems slower over there on the right. But let me show you how intuitive it is to use. I prompted for sunset lighting at first, and then decided to see what it
yeah,
would look
I'm
like if
seeing
there'd just been a fire
it's
in this apartment.
really,
And then I tried something more extreme, like being underwater at the bottom of a murky pond.
it's not
The real
optimized yet.
benefit you get here is being able to go back to the UE viewport, interact with the assets,
And I think
and
it
see them repositioned
it
this new
thinks
diffusion lens.
oh wait, okay, whatever.
Not only that, but you can try more illustrated looks, like a charcoal drawing or even a watercolor painting. As models
Yeah,
get more
it's
capable
not
and hardware
accurate.
improves, it's not hard to project this workflow forward to a time when diffusion is real-time and temporally consistent.
And it
Okay,
takes
let's look
out
at some
a
other
few
examples.
things too. Like, it took out a few of the photos too. It's not entirely accurate, so yeah.
Unreal Engine scenes restyled by artists in the engine using a variety of sources, some of which are premium environment packs from our friends at Kitbash 3D, and some of which are our own internal assets, including the city sample. Starting from quality source assets leaves less room for interpretation by the models.
I don't know how to feel about
We think
this.
these new UE tools are a force multiplier that will give artists more opportunities for creative iteration on their work alongside the real-time animation, modeling, texturing, and virtual production tools that you've come to count on in Unreal Engine. So this is where we're headed. The MCP server that's enabling all this is experimental, and what you're seeing here for image and video creation will be available early next year. We're on this journey together, and we're aware that for these models to be truly useful, we need to focus on not just lowering technical complexity, but also giving you full creative control over what you're making. Thank you.
Thanks, Pat. That was awesome. All right, so now you see more, even great features, workflow improvements that are all going to help you make awesome games and content. So let's talk about distribution. 2025 was a year of growth for the Epic Game Store, and we're off to a great start in 2026. In our year in review, we reported that December monthly active users reached 78 million, an all-time record for the Epic Game Store. And players spent $1.16 billion in the store across third-party and first-party titles. That's
Oh, wow.
up 6% year over year. If you just look at third-party titles, player spending hit $400 million. That's up 57% year over year. And we now have over 6,000 games in the catalog from over 3,000 partners. We offer multiple ways for you to help your business grow. In June of 2025, we announced that developers would keep 100% of the first $1 million of net revenue per product per year, with an industry-leading 88/12 rev share kicking in after that million. We've got Epic First Run, which gives developers the opportunity to keep 100% of net revenue for the first 6 months before launching on other stores. And we also have Launch Everywhere with Epic, which gives UE developers a reduced engine royalty rate of 3.5%, down from 5% when they sim ship their title on the Epic Game Store. Finally, we continue to push on Epic Rewards, granting 5% back to players on all third-party content purchases that are processed by Epic. Now, last year we had a 20% rewards boost through the back half of the year, and we're seeing players continue to spend at heightened levels using the rewards that they accumulated and earned during the promotional period. In fact, spending through the first 4 months of the year on third-party games is up over 40% year over year. So beyond these great incentive programs, we're really working to connect the Epic Games Store more closely with the Fortnite ecosystem. And that'll give developers access to an even larger player base. Take our collab with Hoyoverse as an example. When players purchased eligible items in Honkai Star Rail on the Epic Games Store, they were granted a Stellaron Hunter Blade outfit that could be used across the entire Fortnite ecosystem, in Battle Royale or in thousands of UEFN games. So some players discovered Honkai Star Rail for the first time in Fortnite. Then they went on to spend on the game in the Epic Games Store, and their spend unlocked a new outfit that they brought back into Fortnite. It's a virtuous circle for both developers and players.
Epic Games really trying to make
30 million, sorry, not 30 million,
yeah,
30.
I'm seeing Epic Games is really trying to make you stay in Epic Games in every shape or form, bro.
Similar collabs planned for 2026, with more coming in 2027.
And what I'm really noticing is that Unreal is becoming more like Roblox, and I think that's really the direction that a lot of game engines are trying to take. The whole like game creation like hub.
We're delivering great incentives for both
oh my
developers
gosh
and players, but we need to make the store experience better. And over the last several months, the team's been hard at work rebuilding the launcher. Our goal here is to dramatically improve performance with reduced cold start times and much faster browsing. We've also been re-architecting the back end of the store, which is going to allow us to ship new player-facing features faster and more frequently. We'll be improving search and discovery, adding a lot of long-awaited community features, and doubling down on delivering an overall better player experience. We are committed to growing the Epic Games Store, and we're not relenting in our mission to give developers access to a high-value global player base with the most favorable terms in the industry. You can learn more about our plans for the Epic Games Store in this session tomorrow. And now that we've covered a bit of what's happening in our ecosystem, let's hear from some of the teams putting it all to work. First, 20 years after Emergence Day, the Coalition is finally telling the story they've always wanted to tell. Darker, more alive, and running at 60 frames per second with hundreds of shadow casting lights. Then, Riot Games is doing something most studios would never attempt, rebuilding a live PC and mobile game with 300 million players on a new engine, all while keeping the live service running. And finally, the small team at Neon Giant set out to build the densest, most lived-in city they could have ever imagined, a city where every frame tells a story and every choice you make becomes a part of that story. 3 games, 3 very different worlds, 1 engine. Up first, please welcome Kate Rayner from the Coalition.
Hi everyone, I'm Kate Rayner. It's great to be able to join you today. Gears of War will celebrate its 20th anniversary this year, and Unreal
Oh my god, I saw the trailer. It looked insane.
The series first debuted in 2006.
Oh, it looks dope.
For Gears of War E-Day, we made the decision to invest in Unreal Engine 5 and start with a blank hard drive and rebuild everything from scratch to achieve the believability of a world in chaos. Emergence Day is the darkest day in our universe, the day the monstrous Locust Horde emerged from the ground to lay waste to humanity. And to truly feel the emotional impact of that loss, we needed to return to a dark and gritty visual style. Light and shadow do more than just set a tone, and with Unreal Engine 5, we've pushed our signature Gears style to the next level. So, let's show you a taste of what we've built. Welcome to the Pay and Save Superstore in downtown Kelowna. In previous games, a space like this was limited to 3 shadow casters in view. With Megalights, we now have hundreds of light sources, all casting shadows at 60 frames per second on Xbox Series X. This TV display wall utilizes animated area lights with light functions that are driven by the video itself fully on the GPU.
Oh.
They each cast eerie and unsettling
Destruction
dynamic shadows with soft penumbra across the scene.
That looks dope.
The Pay and Save is a great example of how we've created environments with geometry collection destructible assets like this tiled pillar.
Oh my gosh.
These dynamic objects cast and receive light correctly, so destruction stays visually grounded exactly the way you'd expect in the real world. Let's check out the freezer section. All these freezers have multiple area lights inside them to simulate that realistic lighting effect of the frozen food section of your local grocery store. During combat, bullets create a dynamic shatter point in the glass. When it shatters, all the pieces collide with the environment using hardware ray trace collisions with physically accurate translucent reflections. It's amazing to see how many light sources there are in here. There are hundreds of them, from the small lights on Marcus's armor to the large spotlights on the ceiling. There is no way we'd ever be able to achieve this effect or have this many ray-traced area lights on current generation hardware without megalights. A staple of the Gears franchise, E-holes are back in Gears of War E-Day. So let's open some up. Without all the monsters in the way, you can see all the volumetrics and smoke lit perfectly. One of the things we're super excited about that was unthinkable in the past is having shadows on every single one of our muzzle flashes. This is a really great improvement that adds to the dynamic combat of Gears with a more believable firing experience that puts you right in the middle of the action like never before. Our game isn't limited to just a single space. We can explore the entire city of Kelowna with tens of thousands of shadow casting lights. Delivering E-Day with this level of visual fidelity has not been easy, but we can iterate so much faster with hardware ray trace lumen compared to the baked lighting we used in the past. With megalights, our lighters are no longer constrained by the number of real-time shadow casters, giving them the freedom to light our game with the same complexity as the real world.
Yeah, I'm seeing the reflection.
And
The
we have
lights are
100
insane.
times the geometric detail in our assets due to Nanite's micro-polygon rendering. All of these systems work together to create a highly scalable engine that allows us to consistently deliver a visual showcase across Xbox and PC. As developers, many of us know there is a difference between a compelling demo and delivering a fully realized vision at 60 frames per second. The Coalition is pushing Unreal Engine 5 and the hardware it runs on to their limits to reimagine the Gears world at an unprecedented level of detail. We can't wait for you to see for yourselves when E-Day launches on October 6th. Thank you.
Okay. Oh. Oh, hell no.
I lost visual! Anyone see it? Negative! I lost it!
Oh. Damn. Always the black character. Always.
Hi, I'm Gina, head of tech at Riot on Teamfight Tactics, or TFT as we like to call it. TFT is an auto battler that we originally built as a game mode on the same engine as League of Legends. We built it fast, about 18 weeks from idea to launch, and then it grew way beyond what we expected. TFT has become a leading strategy game with more than 300 million players across the ecosystem, which is kind of wild to say out loud. We've just announced that TFT is moving to Unreal Engine with our next set, Enchanted Wilds. Rebuilding a live game on a new engine while it's still running is not something most games choose to do. It's years
Obviously.
of work across engineering, art, design, and production, and that
Yeah, and it's not even just that, like, sometimes the entire workflow changes. It's not even just that, sometimes the game just doesn't respond the same way. Even like when it comes to changing Unreal versions, for example, going from, let's just say, 5.5 to 5.8, a lot of like studios, or when they're making a game, or they are while the game is still like out, no, not out, but like while they're making the game, they're not really willing to do the change, mainly because the jump might just break the entire code. So this was ambitious. I'm surprised they even did that.
It gets even harder when your game is still shipping new sets, events, everything to players on a regular cadence.
Yeah.
But that's what we decided to do. I
Wow.
joined Riot to work on TFT, and about 6 weeks in, we made the call to move the game to Unreal. And pretty quickly, we realized this wasn't just about moving engines. It was about what became possible. Building on shared technology, reusing more of what we create, spending less time rebuilding foundations, and more time building TFT.
And this is one of the reasons why I think most game, I can't remember, but most game companies would rather use Unity or Unreal, mainly because you're basically separating your workforce into two spaces. One to make an engine, to update the engine and everything, and making the games. And it's kind of hard to do that. It's kind of something that's very tough to do. That's really not recommended. Aside from, I think one of the game Eugenics, I think the creator just said, I think I'd rather just make my own engine because I can do it. Now, most people shouldn't do that, but I do understand why they made the decision. I'm still surprised they even made the decision, especially like they were still like in production of making the game. But for the future, this might have been the smartest decision. So, I applaud them for the risk.
Example is the gameplay ability system. It gives us a more structured and flexible way to build gameplay as the game grows. And
Yeah.
for a game like TFT, where every set brings new mechanics, content, and ways to play, that kind of common foundation matters a lot. It gives us shared building blocks, abilities, attributes, and effects that can be reused across very different parts of the game. And that
Yeah.
lets us move faster over time. With Unreal, we had to rethink how the game was built. Architecture, networking, gameplay, even the way the game data is structured had to change. The early versions of the game in Unreal just didn't feel right. Performance was rough. We had builds running at around 12 frames per second in an 8-player game.
That's Unreal.
Which I'm sure all of you can imagine was not exactly the target. So, the first goal for us wasn't innovation. It was parity. We had to get TFT back, and that meant reworking a lot of systems inside Unreal. Some gave us a strong starting point, others required significant customization, and some we rebuilt from scratch. For example,
Unreal,
networking. As we
yeah.
built more of the game and added more content, we started to hit limits. With a huge number of gameplay actors in
Unreal,
the
I feel
default
like
replication approach wasn't enough
it
to
has
meet
a
our
lot
server
of
bandwidth performance
optimization
targets. So, with Epic's
issues.
help, we evolved our approach, adopting Iris networking with push-based replication and faster
But
ways
it's
to
so
get
geared
performance we
towards
needed.
artists,
The
though.
hard part
Oh
wasn't
my
getting
god, I
something
love it.
working, it was making it work at scale. Gameplay was another big one. We leaned heavily into the gameplay ability system. It's powerful and helped us get something up and running quickly, which, as many of you know, matters a lot early on. But TFT has sets, modes, and gameplay content that don't always ship on the same timeline. And pretty quickly, we realized we needed a better way to organize all of it. So we ended up using the Game Features plugin to give that content clearer boundaries and a more scalable way to share systems. And that gave the teams more freedom to build. And then there's mobile. A huge part of TFT is that it runs on a wide range of devices, including low-end mobile hardware. That didn't change just because we moved engines. And while this has been one of the hardest parts of the migration, it's also one of the reasons we made the move. Mobile is a huge part of how people play TFT, including me, so we invested deeply in custom rendering, memory management, and scaling the game across devices, working closely with Epic to get TFT running where we needed it to. But we're still early in that journey. We're content migration. I'm guessing a lot of you already know where this is going. TFT has thousands of assets across art, animation, VFX, and audio that had to be migrated. And every type of content broke differently when we brought it over. VFX alone was a massive amount of work. We weren't just converting assets, we were moving between fundamentally different systems. Getting thousands of assets into the engine was one challenge. Getting them back to the quality bar that players expect was another. And we really underestimated how much time this would take. So a huge part of the effort became building the tooling and pipelines to fix, convert, and validate all that content at scale. And that's where Unreal's extensibility really mattered. We could build the systems we needed to make this possible, because there was no world where we were rebuilding all of that by hand. And we kept running into the same pattern everywhere. Unreal gives you a lot, but getting from Unreal to TFT still took a massive amount of work. but we're already seeing the impact of Unreal across TFT. More of the game is built on shared foundations. Mobile and PC share much more of the same UI
If
and
this
underlying
is
systems,
an
and we're
Unreal,
able to build on technology and capabilities that exist across Riot. And that's the biggest thing Unreal gave us. Not a feature, leverage.
wow.
But this move isn't for everyone. For TFT, this is what will let us move faster, take bigger swings, and keep delivering the experiences players expect. Because for us, this is about building TFT into a forever game that players can keep coming back to. Players will get their first opportunity to play TFT on Unreal in just a few weeks. And honestly,
Okay.
I hope players pick it up and say, yeah, this feels like TFT. Because if we've done our job well, they won't be thinking about the engine at all. They'll just be playing TFT. Thank you so much. I hope you all have a great Unreal Fest.
Wow. This must have been a, I mean, like I said, it's a real challenge though. We'll see.
I'm Tor Frick, Creative Director at Neon Giant, here to talk out-of-the-box UE4 tech to its limit. We knew that our best starting point would be building a game around the core feature set of Unreal 5, because a small team like ours needs to work with the engine, not against it. We realized early on that out-of-the-box wouldn't be enough. We had to push beyond the defaults and build our own workflow inside UE5 to make the world we wanted. We're proud of what we did with the Ascent, and No Law is the next step in that same approach.
Okay.
Our constraint was specific. We didn't want the largest world, but the densest. A city that feels lived in at every scale, where every corner carries history and every surface tells a story. Port Desire is shaped by human clutter, cramped market alleys, layered graffiti, worn stickers on electrical boxes. It's a story with every frame, from a messy apartment where characters go about their lives to the skyline of the city. As a relatively small team, that ambition came with real challenges. We wanted extreme detail everywhere, but we also needed stability and performance without hand optimizing each location. For us,
Damn.
the answer wasn't a single.
Y'all wanted everything. Nah, that's crazy. He wanted great quality, great performance, great everything, bro. This is kind of crazy.
System, but a shift in how we build the world. We prioritize density over scale, and we built a pipeline that let artists craft spaces without constantly stripping detail back and without relying on procedural generation. Analyse is what made that approach viable. It lets us keep a high level of detail across surfaces without treating every asset as a trade-off.
So they just made the city smaller, but it's really packed and dense. I can tell from the room.
It allows us to have details in every nook and cranny and tell a million small stories.
Okay.
We have more objects in any given frame than the entirety of the Ascent. With this
wow.
we can preserve detail and density in every corner, from the smallest bolt on a freighter to the city as a whole, with no invisible walls and no loading. We built tools inside Unreal to help our artists handcraft the entire city, alley by alley, building by building, block by block.
Okay.
To show Port Desire's full range as an urban city overrun with vegetation, we needed dynamic lighting. From the cozy lush midday sun to the darkest and most dangerous alleys where even the bright neon light does not reach. The challenge was maintaining a fully dynamic day, night and weather system without unpredictable frame times. Lumen gives the foundation for fully dynamic lighting, and mega lights let our artists focus on the believability of the space instead of tuning every single light source. Every believable space needs dozens or hundreds of individual light sources, from the smallest blinking electronic warning light on a camera to the large neon signs above a marketplace. Mega lights allow us to retain the visual fidelity bar we're aiming for while keeping performance considerations low. Once everything is dynamic, it starts to affect the gameplay in more direct ways. Players can shoot out a street lamp, flood a space with a flashlight, or they can leave an area in darkness and have the AI NPCs react to light and shadow, shying away from glare, searching through darkness,
Oh wow.
or escalating when something feels off.
Let's see who got the bigger gun, motherfucker!
We need a mass framework to drive our
That's
craft.
pretty cool.
NPC density types shift based on time of day, region, and weather. In the slums, a storm clears the streets, but in the more sinful parts of Port Desire, even heavy rain won't slow things down. Mass
wow.
simulate thousands of characters at once, over 3,000 at any given time, which is also more than the entirety of the Ascent. So the city always feels active, no matter where you are. We're also using MetaHuman, paired with our own character randomization system. Together with MetaHuman Animator, we can generate and bring to life thousands and thousands of variations of characters, so that the main characters and the extras in the background are all unique. We wanted a world that reacted systemically to the player, without us having to hand-place effects and destruction. Filling a world of this density and scale with contextual effects while maintaining performance and interactivity was one of our key challenges. By combining PCG and Niagara data channels, environmental effects are procedurally populated where appropriate. Wherever artists place trash or leaves, particles will spawn dynamically based on wind, weather, and player actions. Shoot a bullet or throw a grenade, and particles will move out of the way. We combined chaos physics and their own GPU-driven solutions to support tens of thousands of moving objects.
Oh!
The result is a reactive environment, where smoke lingers, embers drift, and broken glass stays where it fell. Creating NOLA has been the process of finding where the engine ends and our custom tools begin. Achieving this level of density, lighting complexity, and systemic reactivity was previously impossible for a studio of our size. By leveraging UE5's latest tech to bypass traditional development bottlenecks, we have finally been able to build the uncompromised version of the world we wanted to create for years. We can't wait for you to experience it. Thank you.
Okay. This is crazy. I might stop the video right there.
Hello, everyone. I lead the Fortnite developer relations team here at Epic, and I'm here to talk.
Oh, okay. This is Fortnite. Okay, I'm gonna end the video right there. This was more, seems to be about, change of workflow, how generative AI is gonna change the workflow in image creation. This was interesting, good and bad. So yeah, I'm gonna make another video for probably another 30 minutes. So we'll see, maybe 45 minutes. So yeah, see y'all in the next video.